Working on a large Stuart model steam plant. This is part 5, a more scientific test run to make sure that the pump will fill the boiler under pressure. And I must admit it's looking very encouraging. The flow is good and there's no sign of any non-pumping going on. Previously this pump would not even pump water back to the tank that it was getting it from. So why not, I hear you all ask? The answer is surprisingly simple, and at this stage I would normally say like a girlfriend that I used to have, but this time I'm going to say because I didn't spot the obvious problem. Why did this pump not work before? For that you have to understand how the water chest works. The water enters at the bottom, underneath the plate that holds the 4 inlet valves. And originally the gasket for this part of the engine was a big gasket with a big central hole cut out. But that's no good. Each of the valves needs to be in its own separate compartment. The best way to think about it so you understand what's happening is to look at the water pump piston. This goes back and forth in the cylinder. As the piston inside the cylinder moves away from one end, it sucks water into the cylinder. And the water that's already been sucked into the cylinder at the other side of the piston is getting pumped out up into the top chamber. This is a double acting pump, so it's all happening at the same time. And it's times 2, remember, because it's a duplex, a twin. The bottom 4 valves work independently, completely independently of each other. There is one valve that corresponds to each side of the piston in the cylinder. And it would seem that the main problem was that the gasket was cut out in such a way that every stroke of the piston in the water cylinder would suck in the water from the main inlet through any valve it wanted, or all of them. In principle you would think this is fine, but it isn't, clearly, as the pump didn't work with the gasket in this way. The new gasket that I made for the inlet side of the water cylinder is entirely different to the one that was originally fitted. And because the holes in the gasket are cut out for the individual valves, each valve will open separately depending where the piston is in the cylinder, on the inlet stroke. And on the outlet stroke, the valve will be forced onto its seat as the water is pumped into the upper cylinder, and then to the outlet to the boiler to feed the boiler with water. The more scientific test I'm talking about you're looking at. This is my boiler test rig, and I've partially dismantled it in order to connect the duplex pump where the hand pump is normally connected. And then on the end of the main outlet pipe from the test rig, that's the one after the pressure gauge, I fitted a small tap. And by restricting the flow of the water using this tap, I can simulate the pump feeding a boiler. You can see what I mean in this clip. As I close the valve, the pressure goes up on the pressure gauge as the pump moves. The pump's valve timing is not right. I'll be looking at that later on in this episode. But I'm not bothered about it at the moment. I'm only bothered whether the pump will actually pump water to feed a boiler. When I tried to get all the silicone rubber out of this pump, it really did drive me mad. And it would pump under pressure for a very short time. When I squeezed the rubber pipe, it was okay, but then suddenly all the pressure would disappear. Why is the pump looking so wet? There's your answer, the pipe keeps coming off. And every time the pipe comes off, and it did it a lot more than this, I get very wet. My right leg is very wet indeed. But one has to suffer for one's art, darling, so I'm still here, braving the wet. I tweaked the valve timing and the pump's not right, but it's getting better. A good sign that it's working okay is when I lift the water inlet pipe out of the water to get rid of all the water in the inlet pipe, and then I put it back in, and the vacuum created by the pump sucks the water back through to the pump. So if the pump will pump air, it will pump water even better than it pumps the air, because water of course is more dense. And this is what it sounds like when the pump is just pumping air. The water's a bit cloudy now, so it's time to change it for some clean stuff. I'm trying to flush out all of the waterways in the water part of the pump to get rid of any silicone rubber particles or gasket particles, or generally anything that shouldn't be in there. In this clip I've almost shut the valve, so now the pump is working very hard, and then guess what happened? The pipe came off and I got wet again. I use this silicone rubber tubing that's available from eBay, readily available and very cheap, because it's convenient, but it does have its limits, and my right leg is really wet now. It's time to look at the valves in the steam chest, so I'm removing the nuts. I'm doing this in high speed so that it doesn't take too long. With all the small brass nuts removed, I'm using a craft knife to separate the gasket from the steam chest cover. And what I see inside is not good. Look how rusty the bolts are. These are mild steel bolts. They really need to be stainless steel or phosphor bronze. Luckily though, they are not rusted in place, so I'm taking these out. I'm temporarily going to refit them, but at least I know about it, and I'll either make some 7BA stainless steel bolts or maybe buy some from Blackgates Engineering. One viewer messaged me and said he was working on a full-size duplex pump and was looking forward to the part where I show the valve setting. So here we go. Here's a shot of the slide valves in the steam chest, and as you can see, when I push the rod fully back, not only is the valve uncovering one of the ports, it's uncovering the exhaust port as well. This is not right. All you have to do is move one of the piston rods to the end of its stroke and set the valve position so it's fully uncovering one of the ports. Then you move the piston rod to the other end and see what happens, and it's a bit of a compromise, as long as when the piston rod is at each end of its stroke, the ports on the port face are uncovered an equal amount at each end. And because this is a duplex pump, you have to repeat the process for the other side. But there's one thing that I've missed out. It is most important that before you do any adjusting of the valve rod, make sure that the front and rear adjusting nuts are also set to an equal amount at each side on the threads. You can adjust your way out of this, but it's better if the threads look the same on both of the valve rods. This is a slow motion sequence, and as you can hear, it's sounding quite even now. Although I will be going back inside this steam chest for a couple of reasons. One is to change the bolts for stainless steel, and the other one is to fix the problem of the two middle studs pulling out of the main casting. And that's it for this episode. I'm just blowing away all the dust and dirt and grime using the airline followed by a cloth. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.